Today's lesson is on angles of polygons. First of all, a polygon is a closed figure formed by a finite number of segments. The sides intersect only at the endpoints. Here we have a convex polygon. It is a quadrilateral having 4 sides. This, however, is not a polygon because 2 of the sides intersect interior to the polygon. This is a polygon, however, it's a concave polygon. And of course, a sphere or a circle is not a polygon. We can name polygons by the number of sides that they have. You should be familiar with these names, but it doesn't hurt to review them. A 3-sided polygon is a triangle. A 4-sided polygon is called a quadrilateral, and we have several specialized quadrilaterals that have their own unique names. We'll discuss those later on in the chapter. 5-sided polygon is a pentagon. Polygon with 6 sides is a hexagon. 7-sided polygon is a heptagon. An 8-sided polygon is an octagon. A polygon with 9 sides is a nonagon. Decagon for a 10-sided polygon. And a dodecagon for a 12-sided polygon. Likewise, if you have an n-sided polygon, it can be called an n-gon, and you substitute whatever number that is for the number of sides. So a nonagon can also be called a 9-gon. An octagon could also be called an 8-gon. So we have all of these interior angles inside of the polygons, and if we want to know how much they add up to, we can simply look at them from a triangle perspective. First of all, this quadrilateral has 4 sides, and from one vertex we can draw a line and create 2 separate triangles here. We know that the interior angles of one triangle add up to 180 degrees. It follows that 2 triangles will add up to 360 degrees. On this pentagon, 5-sided figure, we can draw 2 segments from one vertex to opposite vertices and end up with a total of 3 triangles. And 3 times 180 is 540 degrees. Here we have a hexagon, starting at one vertex, going to the opposite vertices. Get a total of 4 triangles. 4 times 180 is 720 degrees. So the sum of the interior angles will always be 2 less than the number of sides times 180 degrees. Exterior angles on a polygon form a linear pair with an interior angle, and they're formed by extending the side of the polygon. For example, here we have a quadrilateral, specifically a rectangle, and if we extend the 4 sides, we get exterior angles. They form a linear pair. Since this is a rectangle and it has a 90-degree angle, these exterior angles are also 90 degrees. A triangle works the same way. Extend one side of the triangle and continue on to extend the other two sides of the triangle. And watch this animated GIF. As you can see, a triangle, when we shrink the sides together, those exterior angles form a circle, as do a pentagon and a hexagon. So the sum of the exterior angles of any polygon is 360 degrees. A regular polygon is defined as a convex polygon with all sides and all angles congruent. It is both equiangular and equilateral. Here is a convex polygon. It's a hexagon, a regular hexagon. The interior angles will each be equal to 2 less than the number of sides times 180 divided by the number of sides. So in this case, 4 times 180 divided by 6. The exterior angle will always be 360 divided by the number of sides. So what is the sum of the measures of the interior angles of a 13-gon? We have a 13-gon, which is 13 sides. If we take away 2 and take that times 180, will have the total number of degrees within that polygon. So 11 times 180 gets us a total of 1,980 degrees. The measure of one interior angle of a regular heptagon requires us to find out how much the total is for the heptagon. So 7 minus 2, hepta means 7, times 180. And then we need to divide that evenly by the 7 different angles. So 7 minus 2 is 5. 5 times 180 is 900. We divide that by 7 and we get 128.57 degrees for each interior angle. The measure of one exterior angle of a regular decagon. A decagon is 10 sides. All exterior angles of any polygon add up to 360 degrees. So if we take 360 and we divide that evenly into our 10 different exterior angles, we get 36 degrees. So how many sides does a polygon have if one interior angle measures 135 degrees? That means that we have taken our number of sides minus 2 times 180 divided by the number of sides or angles that there are, and that is now equal to 135. So if we cross multiply here, 180 times the n minus 180 times 2 is 360 is going to be equal to n times 135. Bringing our 180 to the right side, we'll have a negative 360 is equal to a negative, and when we take 135 minus 180, we'll get negative 45. So when we take 360 divided by 45, our result is 8. So we have 8 sides. How many sides does a polygon have if one exterior angle is 24 degrees? If we take 360 and divide it by the number of sides a polygon has and set it equal to 24, that means that 24n is equal to 360, and plugging 360 divided by 24 into our calculator, we get 15 sides. How many sides does a polygon have if the sum of the interior angles is 6,120? N minus 2 times 180 is going to be equal to 6,120. Rather than distribute that 180 into everyone, let's divide both sides by 180. Make it smaller rather than larger. And n minus 2 will be equal to 6,120 divided by 180. So if n minus 2 is 34, then n has to be 36. 36-sided figure. 2 more examples. We can ask you to find the measure of each angle. This is a quadrilateral, which means 4 minus 2 times 180 will be the number of degrees in total for all of those angles. So we have a 360 degree interior angle sum. That means that 2x plus 2x plus x plus x, or 2, 4, 5, 6x, has to be equal to 360 degrees. Dividing by 6, x is 60, and 2x is 120. The same property follows here. We have 1, 2, 3, 4, 5 sides, so it's a pentagon. That means that we take 5 minus 2 times 180, which is 540. 540 should be equal to 120 plus the 2y minus 5 plus the 3y minus 25 plus 2y plus 2y. Combining like terms on the right side, we get a total of 2 and 3y is 5y, 7y, 9y. And 120 minus 5 is 115, minus 25 is 90. So if I subtract 90 from both sides, (9y) will be equal to 450. Dividing by 9, y becomes 50. So we have 100 degrees here. 3 times 50 is 150, minus 25 is 125. 2 times 50 is 100, minus 5 is 95, and our 120 was given. There's the assignment.